I'm back, guys. This is day 9 of doing Codeforces, and today we are going to solve remaining problems of CP31 sheet. Okay, so let's continue. We need the zero. Okay, we need the zero. There is an array A consisting of n negative integers. So non-negative integers, basically array contain consisting of only positive integers. You can choose an integer x and denote bi is equal to ai xor of x for all I, which is limit of I is from 1 to n, where okay symbol denotes xor operation. Okay, it is possible to choose such a number x that the value of expression okay equals 0 XOR of all the values equal to 0. So we have to say whether it is right or wrong. If like it can be shown that if a valid number x exists, then there also exists x such that it has to be between 0 to the power of 8. Okay, each test case consisting of t number of test cases and then the length of an array and then the array with integers. Okay, it is guaranteed that sum of n over all the test cases does not exist under the power of 3, which is okay sum of n, no, it does not exist 1000. For each set test case print the integer x if it exists, otherwise we have to print -1. Okay, so basically we have to do an XOR operation on the array elements, and then we have to take the value x. Okay, and we have to perform that XOR operation between the value x and the result of the XOR of the array. And if it like if x gives the value 0, then we have to print the x, otherwise we have to print -1. And like let's try to understand the test cases first. And here one array size is only one, and its element is one, so then the answer is also one. Why? Because the XOR, okay, first we have to understand what is an XOR. XOR is a bitwise operation, so where the result has to be 0 for the same bits, and for different bits it is actually 1. Okay, let's go on to this. So see here XOR. So for input 1 1, which is same, so that's why here 0, and for 0 0, so both are same input, so again 0 as an output. And for different bits, the input is for different bits of input, the output is actually 1. Okay, so that means if an array contains similar elements, then the XOR of the result is 0, right? And if it contains odd number of elements, then the XOR of element is any of the element from the array, which is not same or maybe same or different. So here, as there is only one element, XOR of this one element is actually 1, because we have to perform the XOR operation with the 0, and 1 and XOR of 0 is actually 1, so that's why here output is 1. And basically what we have to do, we have to take an x from the user, and if the text makes the answer XOR is equal to 0, we have to print the text. Yes, here the element is actually 1, and if you take exactly 1 as an x value, then 1 XOR x, which is same, so for same input the XOR result is 0. So as 0 exists, we have to print x value. And let's observe this fourth test case. Here The size is 4 and the elements are 1, 2, 2, 3. So as it contains similar elements, the XOR of these two actually 0. And 0, 1 XOR 1 and 1 and 3 XOR for 1 and 3 XOR what is the value of XOR? Okay, so as 1 contains bits like 0, 0, 1 and 3 contains bits like 1, 1. Okay, and this is binary representation of 1 and 3, and for same input the result is 0 in XOR, and for different it is 1. So the XOR of 1 and 3, which is actually a 2, 1 0. Okay, 1 0 is nothing but 2. Here we are actually performing 2 and 2, and the okay, the XOR of all these operation 1, 2, 2, 3 elements uh, is actually 0, and we are not actually taking the value from the user X value, so that's why is it -1. Okay, let's read the question again. uh, a consisting of non-negative integers, we can choose an integer x and denote bi is equal to ai XOR of x. Okay, for all throughout the array A, is it possible to choose such that a number x, that the value of expression, so uh, we are choosing a number, right? So but we are not actually use that number in bi, or it's like b1 XOR of b2 XOR, I'm sorry, XOR of bn. So this is as the XOR result of a. Okay, so x value of expression equals 0. It can be shown that if the valid number x exists, then there also exists x such that 0 less than or equal to -28. So for each test case, we have to print x value. So if x is exist, to make the 0, and if it is not, we have to print -1, right? Okay, okay, I got it. So the XOR of these 1, 2, 2 and 3 is actually not 0. So that's why we need to print -1. For 0, 1, 2, 3, the XOR of 0, 1 is actually 1. And for 1 and 2, the XOR of 1 and 2. So let's calculate. So for 1, the bit is 1, and for 2, the bit is 1, 0. So the XOR of 1 and 2 is actually 3. Here 1 and here 1, right? So like 0 is represented in binary as 0. Like 1 is represented in 0, 1 and 2 is represented as 1, 0. And for so 0, 1, 1 and 1, 2 is actually 3 and 3, 3. So the XOR of 3, 3. So XOR of A is actually 0. So that's why as 0 is exist, then we have to print 3. Why? Because let's keep it apart. And for 3, so the XOR of 1 and 2 is actually 3, and for 3 and 3, the it is actually again 0. So but we are printing 0 here, 0 as the output. And for XOR of 1 and 2 is actually 3, and 3 and 5, the XOR of 4, 3 and 5. So 1 and 1, so for 5, the binary representation of 5 is actually 1, 0, 1. So the result is actually 1 and here 1 and 0, 1, 1, 0, that is a 6. So the result is 6. Isn't that why we are printing here 6? So it is nothing but we have to find the XOR operation, result of XOR operation, and we have to print the result of XOR operation. Okay, so that's why here we have to print 6, and for here the result of XOR operation is actually 0. like 1 and 2 it is actually 3, and 3 and 3 XOR result is actually 0, so that's why we are printing 0. And for here, 0 1 1 and 1 and 2 is 3, and 3 and 3 again it is 0, but here we are actually printing 3. Why? Because so for the test case 2 the size is 3 which is odd, and here the size is 4 which is even. So for even, uh, so for even we are printing the last element of the XOR, that like we are printing the for the size, for it is also the size is 3. The size is 3. So for odd, okay, for odd we have to print the XOR result. Like here, see, observe this. Okay, 1 2 5, the XOR result is 6, that's why 6, and here the result is actually 0, so that's why 0. And for the test case, so the XOR result is actually 0, but we are not, as the size is n, we have to print the last element of the XOR. Like, okay, and here also the size is even, but here we are actually printing -1 because why? Because the XOR result is not 0. If the XOR result is 0, then we have to print the last element. Otherwise, we have to print the -1. And here, see, observe, as it is odd. So what we have to do for the odd, n is equal to odd, the size is equal to odd, we have to find the XOR, and we just have to print that XOR. The XOR of 1 is actually 1, so that's why we are printing 1 as a result. Okay, I hope you understand. Let's try to code it out. C plus plus code shift code. What is the editor? Okay, so what we have to do, we have to read the number of test cases, and we have to iterate over the test cases. For each test cases, we have to read the size n. Okay, and then we have to take a vector which is int type and which has size n. Okay, then we have to read elements into this vector. Right, and then now we have to find XOR. So in like XOR, uh, XOR. Okay, we can use XOR operation with, like we can perform XOR operation with just the word keyword XOR. Okay, let's, how can I say, XOR result, XOR result, XOR, okay, which is initially 0, and we have to iterate over the array size. So iterate over the array size to find the XOR result. XOR result between the XOR we have and A of I, right? So what operation we have to perform? We have to perform the XOR operation. Yes, this is enough. Then we have the XOR result of the whole array. So actually in question itself, he said that uh, uh, we have to denote the BI, which is equal to the result of the XOR of AI, like element of A and the X. We are choosing the value X, and we have to find throughout the array. Okay, if the result is actually becomes 0, so then only we have to print the x value. But here we are not actually taking the x value according to the test cases. So we find the pattern inside it. Okay, so what did it say? If the size is actually 1, let's say, if the size is actually even, and if the XOR result is actually is 0, then we have to print the value inside it. Like, isn't that the any value? Let's try to say we have to print the value of n minus 1, right? I don't know whether it is right or wrong, but let's try to say n minus 1. Else, that means XOR result is actually not 0. Then we should directly print minus 1 over there, right? And if the size is, what if the size is actually the size is actually odd, then we just directly print the XOR value. So value, right? Let's check this. So that's copy on the test cases and paste here. Let's observe this again. Is there is available of number of no, there isn't available. If the size is odd, okay, have to print the XOR result whenever the size is even, and the XOR result is 0 here. But here it is not actually 0. Not actually 0. We are printing minus 1, and here 0. So that's why we are printing 3. So let's see. 603 minus 1 and 1. 603 minus 1 and 1. Okay, let's copy it and let's submit the code. Okay, okay, it accepted. Yes, our code is right. Oh, prepend and append. Timur initially had a binary string S. He performed the following operation several times. So he had a binary string, okay, possible of length 0. So the binary string possible length is 0. Okay, he performed the following operation several times. So what operation? Add 0 to one end of the string and 1 to the other end of the string. For example, starting from the string 1011, you can obtain either 010. Okay, we can obtain either of this. You are given Timur's final string. Okay, we have a final string of Timur. What is the length of the shortest possible string he could have started with? Oh, we have to find the shortest possible string. A binary string is a string whose character is either 0 or, so the length that he could actually started, I think he has to started from possibly 0. It is possibly 0, but it is not exactly 0. So let's see. Okay, test cases we have to read, and the length of the final string, and then the string, okay, which is contain the characters 1 and 0 because it's a binary string, and for each test case output is single non-integer, so non-negative integer, so it's nothing but an integer, positive integer, and the shortest possible length of Timur's original string. Okay, that integer is actually the shortest possible length of Timur's original string. Okay, note that Timur's original string could have been empty. It could have been empty, in which test cases you should obtain output as 0. So like if the string is actually 0 initially, then we can actually take a 0 or 1, Okay, right? So in that way, in that case, we have to print 0 as the output. So let's observe the test cases and gain the intuition. For the string length 3 and 100, the output actually the 1. So the output is actually 1. And for 0111, the output is actually 2. Why? Because in the first test case, the shortest possible string Timur started with is actually 0. Yes. So for each test case, we have to print what? For each test case, for each test case, if this is the string 100, the final string, the shortest possible string length is actually 0. Length is actually 1. So that's why here output is actually 1. Because we have to add one 0, or we can have to add 0 1 on either side of the string. Let's see, the size is actually 4. That means he started with the size 2, right? So that's why here 2. And for 5, okay, 1 1. So 1 1. So this is not the operation that he the result of the operation of the string. So what is the result of the operation? uh, 0 1 1. What is the result? 5. Okay, so that means uh, like uh, the operation is actually not performed yet. That's why we have to return the length of the string. If the length of the string is actually 0, then we have to print output is actually 0, right? So if the length of the string is actually n, where the operation is not performed yet, then we have to print the size. That's why here 5. And for 6 test case, so 1 0 operation performed, and the length is actually 3 4. Oh, but here the length is actually 0. Why it is 0? The initial possible string that he started with actually 0. Why? Okay, okay. He started with 0, and he append 1 0 first, and then he append 0 1, and then he append 1 0. Okay, so we have to think about this test case also. And for C, so 1 0 and 1 0 and 1 1. So 1 1. This is not operation. So the initial string that for this test case is 1 0 1, where the size is actually 3. Okay, I got it. So here 1 initial string, we have to print its length. So 1 1. And for 2 1 0 initial string, so 2. And check this 1 0, so which is not actually the initial string. It is the string which is an empty string after the operation had been performed. So that's why the size is actually 0, because length of initial string size is actually 0. And 1 1. So here obviously 2 is the output. And for here 1 0 and 1 0, so front 1 and back 0, and front again 1 and back again 1. So this is not the operation. So the size is 1 2 3 and 4. So that's why here the size is 4. So I hope you understand the intuition behind this. So what we have to do, we have to. So what we have to do, we have to read after reading the string. We have to check whether uh, the first and the last characters of a string is actually one and zero, or zero and one. Uh, so if it is, we have to delete that characters from that string. And then if it is not, the size of that string is actually our answer, right? So let's code it out. So we have to take the size, and after that directly we have, okay. Then we have to read a string, before that we have to take the variable of the string. Oh, sorry, okay. So after that we have to read the string. and then uh, the starting value like index of the string is 0, and so is it better to take first, and the last index of the string is actually n minus 1. As it is 0 indexing, it is actually n minus 1. And then okay, we have to perform the operation until first actually less than last. So for each operation, what we are actually checking, whether it is the end and start values of the string is equal or not. If it is equal, then we have to break them. If it is not equal, as it is a binary string, the values are actually 1 or 0, right? So I think this is enough. If string of f is equal to the string of last, then there we have to break. Otherwise we have to increase the first index and reduce the last index, right? Okay, this is enough. uh, let's take this is the string and 1 0, so as it is different, so we actually improving the first index and last index. Now this is where exactly 0, so the loop has started here, like stopped here, and we have to print 1, so we have to print its size. So how can we print its size? The j value and I value. Let's take so if it is equal, okay, I got it. So we just have to print their size, which is nothing but j, the last index minus first index plus 1, because whenever L is equal to F, there we have to stop. If we stop it there, the length is actually 1. That's why we have to add plus 1 here, right? After that, and ln, right? I have a doubt. Let's check it. For the string length 0, so which is a test case 4. So test case 4. So different. So 1 and 0 different. So that's why we have to increment the first and the last, decrement the last. Now 0 and 1. Again we have to decrement the last and increment the first. 1 and 0. Again we have to decrement the first and decrement the last. So this is where actually meet at a common point. Let's run the code, then we actually see then what exactly happened. They are pointing to the value, they are pointing to the value 0 1 0 1 2 3. They are pointing to the value 3 and 3, 3 minus 3. Okay, but we are printing 1 there. Here, come on, let's run the code. Right, come on. Code submission failed. Let's run it again. Number of test cases, and for each test case we are reading string and we are reading n value and that string. uh, I hope we are not actually using plus 1. What happened? Because check this, 1 0 string length, they are actually at same. Okay, okay, the code runs successfully, but here we have an error. E was not declared in this code. Okay, it actually last index L. Let's run it again. actually 0 0. Okay, 125031024. 125031024. 125031024. Okay, the output is same. Let's submit this. Okay, we have to submit the code. Come on, come on. Okay, come on. Uh, if you are taking the string 10, then only the size is 2. So f is 0 and l is actually 1. Okay, 0 is less than 1. Then, and it is actually not equal. Then, so 0 becomes 1 and that 1 becomes 0. So this is where the condition falls and we have to print what is L value. L value is 0 and what is F value? F value is 1. So 0 minus 1 plus 1, which is actually 0, right? Okay, that's why it actually runs and successfully. Come on, we still have to do a lot. Okay, the code is accepted. I hope you understand this intuition. And okay, that's all it for today. Thank you for watching this video.